In the previous video, we looked at building a star feature detector. In this video, we're going to use Visual Codebook and vector quantization to create features. In order to build an object recognition system, we need to extract feature vectors from each image. Each image needs to have a signature that can be used for matching. We use a concept called Visual Codebook to build image signatures. This codebook is basically the dictionary that we will use to come up with a representation for the images in our training dataset. We use vector quantization to cluster many feature points and come up with centroids. These centroids will serve as the elements for our Visual Codebook. You can learn more about this in this documentation available on this web link. Before you start, make sure that you have some training images. You were provided with a sample training dataset that contains 3 classes, where each class has 20 images. These images were downloaded from vision.caltech.edu. To build a robust object recognition system, you need tens of thousands of images. There is a dataset called Caltech 256 that's very popular in this field. It contains 256 classes of images, which you can see here. Also, each class contains thousands of samples. You can download this dataset from this website. So let's move on to our editor and see how we can do it. This is a lengthy video, so we'll only look at the important functions. The full code is given in the buildfeatures.py file that is already provided to us. Let's look at the class defined to extract features. Now, define a method to extract features from the input image. We'll use the star detector to get the key points and then use sift to extract descriptors from these locations. Next, we need to extract centroids from all the descriptors. So we've done it here. Now, each image will give rise to a large number of descriptors. We'll just use a small number of images because the centroids won't change much after this. The print progress is this. Then extract the current label. After this, read the image and resize it. Let's now set the number of dimensions to 128 and extract the features. Use vector quantization to quantize the feature points. Vector quantization is the n-dimensional version of rounding off. You can learn more about it at data-compression.com, which you can see on your screen now. Now, define the class to handle bag of words model and vector quantization. Let's define a method to quantize the data points. We'll use k-means clustering to achieve this. Next, extract the centroids, as we did here. Now define a method to normalize the data. After this, we define a method to get the feature vector. Next, we build a histogram and normalize it. Now define a method and extract these sift features. As mentioned earlier, please refer to buildfeatures.py for the complete code. Let's run the code and see the output. Here you should give the path of the training image file. Let's see the path and copy it right from there. So we paste the path here. You need a lot of patience to give this lengthy path. Now let's run the code. You can see that it's reading all the image files. So it's generated 2 files called codebook.pkl and featuremap.pkl. We'll use these files in the next video. Great! In this video we've learned to create features by using Visual Codebook and vector quantization. In the next video we'll see how we can train an image classifier using random forests.